17.
Okay, 17 on cruiser view.
And so with finding the, like whether it was proving it was differentiable. I
Mhm.
was just wondering, since you would have to prove this continuous, would you have to do all the three parts for the, including the limits?
Basically, to prove that it's differentiable, you just have to make sure that each of the expressions derivative is matching. That's really all. You don't have to go through all the steps. Just have to show that, okay, they share the same slope at that point, and they share the same y value at that point, and that's really all we need.
I could just say, like, put the two equations together, plug into, if I get a good answer that's equal, that could be my justification.
Yeah, that's right. Yeah, that's good enough. Good. Yeah. Yeah, it's also good that you memorize the limit definition of derivative and the alternative definition of derivative and just know how to use it. There may be a question where it's like this, but then there may be a question where I'm asking you to set it up. For 8, okay.
Since if I was exactly on there, I know you just. Does it matter if you
Wait,
go
which
through-
problem? Number 8?
Oh. With the table,
Oh, with the table.
so I'm looking at it. If you back this 2.1.
Oh, okay. Okay.
Rather use the slope formula with the point to the right and to the left.
If you want to approximate a prime of 5, you want to pick the closest to your target. The further you are away, the less accurate you're going to be. So just pick points around it. That's good enough. You have 3 options. So you can pick 2, 2 and 5. You can pick 5 and 7. You can even get away with 2 and 7. Yeah, but anything other than those 3 is too far away. Here, I got a problem for you here. Maybe I'll also do this one in class. How would you go about finding the derivative of this function here? change the one.
Base to the power of 3 or something.
It's 3 times the square root of x to the 7th. So looks complicated, but what's the overarching rule that you would try to use with this? It looks like quotient rule, and it's possible with quotient rule, but is there an easier way to do this problem?
Seven and change that to exponential.
Okay, yeah, definitely convert to rational exponential form. What else? What else can we do? Is there anything that we do to avoid quotient rule here? The hint is that there's only one term below. So if there's only one term below, what can we do? Yeah, we can separate into individual fractions. If we can separate into individual fractions, then we can just clean everything up and treat it like, 3 or 4 different problems rather than one messy problem. So my suggestion is if you only see one term in the bottom, try to avoid quotient rule. I mean, you can do quotient rule and chain, but it's messy, and when you get down to the answer, it may not match the answer choice because you got to clean all that mess up. So the strategy here is again, quotient rule is possible, but if you use quotient rule, you got to involve chain as well. And why don't we do it? Yeah, so here's an example of a problem that is just a power rule problem, right? It looks messy, but we can actually split up. So let's see if we can practice this one here. And how would you convert square root of x to the 7th into a rational form? Okay. Yes, you could bring it up to the top, but if you bring it up to the top, you want to make sure you distribute everything through. So I've seen enough mistakes where I'm going to suggest students to go ahead and split into individual fractions, because when I see students bring this x up to the top, they end up just multiplying with the last term and they don't distribute everything through. So I think the cleaner way to avoid mistakes is just continue to split up and just individualize everything. But yeah, sorry, this is a positive 7/2. I want to leave it in the denominator there. Anyway, so I'm still in the cleanup stage here. No calculus yet. All we're doing is just try to get everything cleaned up here. So now I can start bringing all the variables up to the top. But when you bring your variables up to the top, leave the coefficients below, right? That's not part of the, so I can subtract the exponents here. 5 minus 7 is -2. Now it ends up being a relatively easy power rule problem once we get all the way down to here. So everything before is just algebra. It's just cleanup. The only calculus step is from here to here where we do power rule. So now continue cleaning up. No need to do common denominators. You can leave all your answers and separate fractions.
That be on, will something like that be on this quiz or like, okay.
Yeah, because this is a power rule problem, right? So we need to be able to know how to do this. Even though it looks like a quotient rule, there's no need for a quotient rule. Yep.
For acceleration of velocity, is acceleration always the second derivative of velocity of the first?
Yeah. That's right. Yeah.
Can you go over a variation of the ATM?
So you want to see another version of that, another problem that's similar to that? Okay. Let's see, that's fine. Let's try this one here. and try that one. I'll work through it as well. Okay, so with the piecewise function, we know that if we want these to be, if we want these to connect in a way where our function is differentiable, that means they must connect in a way where the y values are shared and also connect in a way where the slope is shared. That will allow a smooth transition between the two branches. So I can set the two expressions equal to each other. I can find their derivatives and set their derivatives equal to each other. Replace every x with -1. And then now I'm just trying to solve for a and solve for b.
Yeah.
Mhm. Make sure you know your general and your alternate definition of derivative. Could be asking you to set it up, could be asking you to interpret, but it's just good to know how all the pieces fit. X. So the general definition will take you to a formula, but the alternate definition will take you to a numeric slope. So why don't we do an example here? Um, Okay, obviously, you can find this very quickly using Power Roll, but it's good to know how to set things up if I ask you for something in one of the definitions, or if something is presented as one of the definitions, to be able to interpret and to be pull what it's asking for. So why don't we just start from scratch? And the nice thing is you already know how this is going to work out, right? You know it's going to end up being negative 4x minus 1, but we should be able to just fill in the missing pieces there. Oh, I messed up. I messed up. See it. X plus h here. Okay, we should be able to reproduce this result if we were to go through on the alternate side. But the alternative side will take you directly to this number. It's going to bypass the slope formula. It will take you directly here. All right, let's try that. Yeah, let's do that.
How, how do you know the one is included in your function?
Right, now, if I were to ask you to, let's say I replaced all the x's with 5s, then we would not be able to get any hint here because this will be all just a numeric number, right? There's nothing, we lose that, that ability to figure out where it's coming from. But if we stare at this portion here, right? Imagine this was -5 plus h squared minus 5 plus h plus 1. You can look at this and realize, okay, the function that is coming from is -2x squared minus x plus 1. I would not combine these values together because if I add that plus 1 into here, then you lose the ability to do it. So I would separate that plus 1. If there is a constant, it would be there for you to pick it off, right? So yeah, that would be too hard if that plus 1 was mixed into the numeric value here. Okay, let's look at the alternative definition here. Same function. First step is replace every c with the value that you're targeting here. Okay, f of x, replace it with the original function. F of 5, insert 5 into the original function here. Doing something wrong here. F of x minus f of c. It ends up being a hard factoring problem here.
So if we had one like this.
No.
Like that.
Yeah, that factoring was messy, but the idea is that you get it into the form and you evaluate, you know there's a hole because it ends up being 0/0. You try to find that common factor, you reevaluate, and it's going to bypass the slope formula, take you directly to the slope value.
So we won't have to factor something that looks like.
No.
Okay.
What I want to hear more about is that you understand how it fits, right? If I ask you at this point, what is this function? What does this mean? You'll be able to tell me that, okay, this is asking for the slope of this function at 5. If you can pull that information out, you can just maybe even go through power rule to get to the answer without even go through this whole process because you know what it means and how to get there, right? You always have power rule to back you up. You want to avoid this, but still, the more important thing is knowing what it means and how to set it up and knowing the definitions.
Okay. What might we have to draw the graph?
Nope, no sketching graphs. Yeah, so base this off, base your studies off of your quiz review. I know that, some homework problems and some of the AP review are kind of all over the place. I think those are all really good to practice through, but for the quiz, right, ask questions off of the quiz review.
Is there a chance we have one where it's like a product rule inside of a product rule?
Oh, like the one that we saw. Do we see one in here? Oh, product rule within the product rule. That's more of under the quotient, under the chain rule. Under the chain rule section. So yeah, no, we shouldn't have, yeah, there's nothing like that. Yeah, know how to find product and quotient rule in function notation and being able to do those problems like page on 21, page 4 here, page 3. Right, these problems, right? Know how to set those up, get everything set up in function notation, and then plug everything in. Either put information in from graph perspective, sorry, a table perspective, or pull information from a graph perspective, right? If I gave you a graph and if I asked you for the slope, you would just find that slope of that line and put that value in.
For any problem that we have alternate or normal one, I know the definition of derivative, we can check our answers with power. Rule.
Exactly, right. Yeah, all the problems will be simple enough where you can check everything with power rules. It's otherwise limit definition would just not even, it'll be too hard to do if it wasn't a simple equation. Okay, make sure you know your derivative rules, like power rule, natural log, e to the x, and your trig rules, right? So make sure you look over your derivative rules.
It's not about the quiz review, but we have the like the homework packet. Can you check those answers with like Wolfram Alpha, like with that? Yeah, you the right.
Maybe, I don't know if it's going to present you the nice cleaned up solution that we have, but are you asking about where you're doing some problems that wasn't assigned to you and you want to just double check? I will see if I can make the solution key available so they can check the other problems, but I got to figure out how I can put it online without it being where it's just for class. So maybe, yeah, I'll try to find a way to put the whole solutions up, but maybe I can get that in by next unit.
Okay. Thank you.
Mhm.